In this video we're going to continue looking at solving simultaneous equations, and we're going to first of all remind ourselves of our two mantras. They are eliminate, substitute, check. That's the one that tells us what we need to do. First of all we eliminate a letter, then we substitute in our answer, and then we check our final answer. And also same sign, subtract, different add, and that tells us whether we're going to subtract our two equations or add our two equations to get to eliminate one of the variables. So let's look at some examples. Now these ones are a bit different to the ones we've seen before, but our process is very similar. There's just an extra step we need to do first. Now here you will notice that neither the x's nor the y's have the same coefficient, have the same number multiplying them. And also, neither of them is a simple multiple of the other. So we can't just multiply one of the equations to get the same number of x's or same number of y's in the other equation. So in this one we're going to have to do something a bit different, but very similar in many ways, and that is multiply both of them. And what we have to do is, because we have 4 and 3 in the y's here, we're going to want to get them so that they're the same. We're going to multiply them so we get the lowest common multiple of both of those, which in this case is 12. So what do we have to multiply 3 by to get to 12? Well, we have to multiply that by 4. And when we do that, we get 8x plus 12y equals 36. And similarly, what do we have to multiply the 4 by to get to 12? Well, we need to multiply that one by 3. And that gives us 15x plus 12y equals 57. So that's our first step. We have to multiply both equations so that they have the same number of y's, or x's, as we'll see in a moment. Now, just to make this easier, we're going to label that one 1 and that one 2, and we're going to do the second equation subtract the first equation in this case. And the reason we're subtracting is because the signs in front of the y, the signs in front of the variable we're eliminating, are the same. So we're same sign subtracting here. So 2 minus 1, well 15x minus 8x is 7x. The 12y and the 12y cancel, and 57 minus 36 is 21. So when we divide by 7 we get x equals 3. And then we're going to substitute x equals 3 into our original equation, and we get 2 times 3 plus 3y equals 9. So that's 6 plus 3y equals 9. So taking away the 6 we get 3y equals 3 and y equals 1 as our answer for y. Finally, we can just check with the other equation, the 5x plus 4y, so 5 times 3 plus 4 times 1 is equal to 15 plus 4 is indeed equal to 19, so we've got the right answers, x equals 3 and y equals 1. Another example here, and we're going to do the same thing. We are again going to try and get the y's the same. In this case we have 3 and 4, so we are going to use 12 again. So we multiply the top one by 4, and we're going to multiply the bottom one by 3. So when we multiply the top one by 4, we get 16x plus 12y equals 60. And when we multiply the bottom one by 3, we get 15x minus 12y equals 33. Let's label these up. We've got 1 and 2 there. And now we've got the different signs in the variable we're eliminating. So we're going to add them together this time. So we're going to do 1 plus 2 this time. 16x plus 15x is 31x, and 12y and 12 plus minus 12y disappear, and 60 plus 33 is 93. And dividing by 31 we get x equals 3. And then substituting x equals 3 into number 1, but the simplified version, into this one here, we get 4 times 3 plus 3y equals 15. So 12 plus 3y equals 15. Take away that 12, we get 3y equals 3, so we get y equals 1. So we've got two answers, x equals 3 and y equals 1. Once again, we're going to check using the second of our two equations. So 5 times 3 minus 4 times 1. 5 times 3 is 15, minus 4 is indeed 11. So we have got the right answers. Here we have another example, and we're going to do much the same, but this time, just to show you how it works, we're going to get the x's to have the same values and eliminate the x's. So this time we have 3 and 2 for our x coefficients, so we're going to need to multiply the top one by 2, and we're going to need to multiply the bottom one by 3, which gives us 6x plus 8y equals 28, and minus 6x plus 15y equals 18. Now we are eliminating the x's, so it's the sign of the x's that matters, and the x's have different signs, plus 6 and minus 6, so we're going to add. So this time with our equations 1 and 2 we're going to do 1 plus 2, because we need to add them together, and when we do that the x's cancel out. 8y plus 15y gives us 23y, and 28 add 18 gives us 46, and then divide by 23 we get y equals 2, and then substitute y equals 2 into our original equation. We get 3x plus 4 times 2 equals 14. So 3x plus 8 equals 14. So 3x equals 6, x equals 2. Giving us our answers of y equals 2 and x equals 2. And then finally we check them in the second equation. So minus 2 times 2 plus 5 times 2 equals, well, minus 2 times 2 is minus 4, plus 10 is indeed 6, so again we have got the right answers. This is the final example we're going to look at, and again we're going to eliminate the y's. So to get the top one and the bottom one having the same y values, we're going to need to get 28. So we're going to multiply the top one by 7 and the bottom one by 4. That gives us 21x minus 28y equals 14, and 20x minus 28y equals 12. We have the same sign for the y's. They are both negatives, but it is the same sign, so same sign we subtract, and we're going to do 1 minus 2, and that gives us 21x minus 20x gives us just an x. Minus 28 minus minus 28 is minus 28 plus 28y, which is 0, which is what we wanted. And finally 14 minus 12 is 2, so we get straight away that x is equal to 2. Then we're going to substitute x equals 2 into the first equation, so we get 3 times 2 minus 4y equals 2. So 6 minus 4y equals 2. Subtracting the 6, we get minus 4y equals minus 4. So y equals 1 is our second answer. And then finally we're just going to check that in the second equation. 5x minus 7y equals 3. So 5 times 2 minus 7 times 1. 5 times 2 is 10. Minus 7 is indeed 3. So we have got the right answer. So solving simultaneous equations, we always use eliminate, substitute, check. And we always use same sign, subtract, different, add. If we do not have the same number in front of the variable we want to eliminate, then we may have to multiply one of the equations or possibly both of the equations so that we have the same number multiplying that variable, and then we can do the elimination as we did with other simultaneous equations.